Hello. So today we're going to talk about parallelograms. A parallelogram is a quadrilateral with opposite sides parallel. For instance, this is a parallelogram. Okay, I think you've seen it enough. We actually have some cool, interesting properties with parallelograms. So, opposite sides are congruent in measurement. So, the top and bottom ones here are congruent in measurement, and the left and right ones here are congruent in measurement. Now, because of this and the idea of congruent triangles, we actually end up seeing that this angle and this angle are also congruent, or in other words, opposite angles are congruent. Just imagine if you drew a dotted line here across this diagonal, then you would see that, oh, these triangles have to be the same, therefore this angle has to be the same. Okay. Well, same result comes if you draw it across the diagonal this way. So we end up seeing that these two angles are congruent as well. So opposite angles and opposite sides are congruent in a parallelogram. And so anything that's a parallelogram, including squares, including rectangles, including rhombuses, have this feature. And that's kind of cool. Well, what does that mean? That means that if you are given the two sides, or if you're given the two sides, you automatically know what the other two sides are, and you can actually find the angles because you know enough about triangles in order to find out that information possibly. If you're given a diagonal with that as well, you definitely can find everything. So yeah, and I'm going to show you some other things that you know from this. Well, because the angles in a quadrilateral add up to be 360 degrees, how do I know that? Oh, well, if I were to draw a diagonal here, I would say I have two triangles. 180 plus 180 equals 360. Or there was that formula that you may have seen before. 180 times n minus 2 is the sum of the interior angles. So if we put 3 in here, 4 in here, 4 minus 2 is 2. 2 times 180 is 360 degrees. Okay, so the interior angles sum is 360 degrees. Okay, well, because that's 360 degrees, if I'm given one, and the fact that opposite angles are congruent, if I'm given one angle, I automatically know everything else. But why is that? Well, when I add all four of them together, this should be 360. And since this side is the same as that side, in reality, what I actually have is that this part must be 180 and this part must be 180. Well, that means that adjacent angles, so we know opposite angles are congruent. We also know then that adjacent angles are supplementary. In other words, they're 180 degrees when I add it up. Okay? Well, let's look at an example. So if I told you that this was, I said this was 50 degrees, you automatically know this side is also 50 degrees. Well, because this has to add up to 180 degrees, and these two are the same, or sorry, have to add up 360 degrees, and these two are the same, we know we have 360 minus 50, we have 260 degrees left over. If we divide it up, we get 130 and 130. Okay? Well, 130 plus 50 is 180, which is what we said. These adjacent angles, or the angles next to each other, should be supplementary, or they should add up to be 180 degrees. All right, so that's the generalization with parallelograms. If we were to draw a diagonal now from this, we would be able to find the length of diagonal based off of law of cosines if we know these two sides here. And then we can find out everything we want about the parallelogram. Now, let's look at some other examples of parallelograms and different things we can do with them.